So for class today, we are going to be using a strategy and then called cubes. And that's all you have to do online, students or students who weren't in class because you were not able to partake in the COVID discussion. So our agenda for today is the check-in, this daily work activity, and then the COVID-19 discussion. Again, this is something that you probably weren't able to participate in because you did not attend class. The objective for today is to be able to use the cubes strategy to solve word problems. The cube strategy is a way to approach long word problems to help you figure out the best way to solve the problem. It stands for circling numbers, underlining the question, box action words, eliminate wrong answers, and solve with evidence. This is designed to be done with pencil and paper, but since we are online, I have created a new virtual version that we will use. The virtual cube strategy is still the same acronym, CUBES, but looks a little different. For C, you are going to highlight any vocabulary words, keywords, or numbers in a light red. For U, you are going to underline the question. And by underline the question, I mean you are underlining only the sentence that ends with a question mark. Many times with word problems, there are several sentences in the whole reading, so you only need to underline the part that's directly asking you the question. For B, you're going to highlight action words in green. So those are going to be your verbs, your things like running, pushing, pulling, applying, accelerating, acting, things that are demonstrating or showing action. For E, you are going to highlight wrong answers in black, and I'll show you how to do that. And then for S, you're going to put your final answer in this color purple. What we're going to do now is I'm going to show you two example problems. For those of you watching this, you need to listen and fill out your slides 7 and 8 to match mine exactly. First, I'm going to read through the problem. Two students are working together to build a birdhouse. Student 1 applies a force of 10 newtons to a wooden board in order to slide it across the table to student 2. If the force of friction resisting the student's push is 4 newtons, what is the net force acting on the board? The first thing I need to do is my C, which is online going to be highlighting important vocabulary words or numbers in red. I am going to read through my question again and start highlighting things that fit that criteria. The first sentence, two students are working together on a birdhouse. That's just background information setting up for the question, so I don't need to highlight anything there. Student 1 applies a force. Okay, force, that's one of my vocab words. And I'm going to highlight in light red 3. It's the red directly below the bright red. So student 1 applies a force of, a number, 10 newtons, to a wooden board in order to slide it across the table to student 2. Okay, so student 1, she's important because she's sliding, so I'm going to go back and highlight her, is sliding a force to student 2. Alright, now let's go on to the next section. If the force of friction, vocab word, resisting the student's push is 4 newtons, what is the net force acting on the board? Okay, I need to highlight 4N because that's 4 newtons and that's vocab. And then net force is also a vocab word. Now I am completely done with C for this first part. Next up is U, which is underlining the question. So I'm going to underline what is the net force acting on the board, because that is what the question is asking me to solve for. Next up is B, which means I'm going to highlight my action words in green. So those are going to be applies. Student 1 is applying force. I'm going to make that a bit darker. So I want you to use green, light green too, all right? Student 1 applies a force to a wooden board in order to slide. All right, that's talking about movement, so that's an action. It across the table to student 2. If the force of friction resisting, okay, that word resisting is a verb. It's an action word, and resisting means pushing back, fighting against. If someone were to hypothetically kidnap you, you probably want to push and fight back, so you would be resisting. And then my last highlight, let's see what is the net force acting on the board. All right, I am now done with green. Now I'm on to step E, which is eliminating the wrong answers. So my question is, what is the net force acting on the board? And I know I have student 1 is pushing 10 newtons of force on the board, but the friction from the table is pushing 4 newtons. And I know that net force is the total force applied to the board. Okay, well, it can't be 4 newtons because I have to account for 10 newtons and 4 newtons, and I can't only do part of the force. So if 4 newtons was the correct answer, that means I was ignoring the 10 newtons present. That means also 10 newtons isn't correct because that means I would be ignoring the 4 newtons of force on the board. So that leaves me with 6 newtons and 14 newtons. Well, I have 10 newtons of force going one way, but it says the force of friction is resisting the student's push. So it's pushing back against the student's push, which means the forces are going in opposite directions. And I know that whenever I have force going in opposite directions, I need to subtract. So 10 minus 4 is going to be 6. So that gives me my correct answer of 6. I'm going to put that in purple, this purple right here. And I know that can't be 14 because that would require me to add 10 and 4 together, which would be incorrect because the forces are not going in the same direction. Next up, I have another problem, and you're going to drag and drop these squares for this activity. Read the question first. The diagrams show forces acting on a toy car as it moves to the right. Which diagram shows the toy car that will most likely accelerate to the right based on these conditions? All right, so first I have to go in with C and highlight any key words, vocabulary, or numbers. All right, so we have forces. These forces are acting on a toy car. All right, I see the toy car in my picture. And then it says it moves to the right. Right is a direction. That's important, so I'm going to highlight it. Which diagram shows that the car will most likely, so I'm going to highlight most likely because that means it's not 100% going to, but it probably will. And I want to know if it'll accelerate to the right. All right. And I'm talking about my toy car, so I need to make sure I have toy car highlighted. Now I'm ready to move on to step 2, which is underlined for you. So my whole question is, which diagram shows the toy car that will most likely accelerate to the right based on these conditions? So it wants to know which one of these pictures will show us that the car is going to go towards the right. Next up, what I have to do is B, which is highlight my green action words. So my first one is going to be forces acting, because I'm going to be looking at forces acting on the toy car. And then my next one is going to be accelerate, because accelerate means to speed up, to move fast. So now I need to start eliminating answers. But before I do that, I'm going to reread the question. which diagram shows the toy car that will most likely accelerate to the right based on these conditions. All right, so let's see here. I'm going to start with H because it has 10 newtons going towards the left and 10 newtons going towards the right. I know that answer can't be correct because it's two forces going in opposite directions that are equal, which means it's balanced, so the object won't be able to move at all. And if the car can't move, it's not going to accelerate to the right. Next, I see I have 10 newtons pulling the car to the right, then I have 13 newtons pulling the car to the left. Well, the 13 newtons that's pulling the car back to the left is stronger than 10 newtons, so that means the car is going to go back, not forward. So that can't be it. Now I'm left with two options, F and G. Here with G, I have 10 newtons pulling to the left and 8 newtons pulling to the right. Again, the newtons pulling back against the car have more force. Therefore, the car is going to move back towards the left and not be able to move towards the right. This means that F might be the correct answer, so let's think about it. I have 6 newtons pulling to the left and 8 newtons pulling to the right. The 8 newtons that's pulling to the right is a stronger force than the 6 newtons, so the car is most likely going to start moving towards the right when it's in this position. So now I'm going to drag over my green circle and put it around F. So this is exactly what your slide needs to look like before you turn it in. You will get a grade on this when your two slides, 7 and 8, look exactly like mine in the video.